Use the left-hand Riemann sum to estimate the displacement of the given velocity function. So the area underneath the velocity curve represents the displacement. So the first thing I'm going to do is I'm going to sketch a graph here. This is what my graph looks like. It looks like I'm kind of going like this, increasing my velocity in that kind of pattern. Okay, so I want to use the left-hand Riemann sum to estimate the displacement. So I'm going to use the left-hand value to be able to calculate the area. So the left-hand value here is negative 22. So in this space here, in this interval, we went negative 66 meters. For the next interval, the left-hand value is 0, so we're going to have 0 displacement. In the next interval, this interval here, we're going to have a height of 10, a width of 1, so that's going to be 6 meters of displacement. In the next interval, we have a height of 12 and a width of 4, so this area is going to be 48 meters. So to estimate the displacement here, we would just add those all up and we end up with an area. So this is going to be 4 times 12. Yeah, that's correct. So our positive area is 54. Our negative area is negative 66. So the net displacement is equal to, and I'll write this out, so negative 66 meters plus 54 meters, and that works out to be a negative 8 meter displacement. Example 2, the vertical distance between y equals x and y equals square 2 root x represents the side length of a square whose cross section comes out of the xy plane. So first thing is, let's draw this function in the area that we are looking at. So there's my graph. Y equals x would be this function here, and 2 root x is going to be a function that looks like that. Okay, so maybe I'll just exaggerate that a little bit more so that we can see the graph like that. And we want the intersection point here. So where y equals x is going to be where x is equal to 2 root x. Okay, so in this case here, it's the area will be, so this intersection is at 0, and when we solve this, we end up with square root x is equal to 2, so x is equal to 4. Okay, so the intersection, the right-hand edge is 4. So the cross-sectional areas, so this is going to become a 3D shape, so the cross-sectional areas of this 3D shape, it's going to be represented by this line, so the distance between those two lines, and it's going to be a square coming out of the plane. So it's kind of hard to draw that, but imagine a square coming straight out of that plane. So there's our cross-sectional area, and if I want to get the volume of this is going to be the area of the square, so we'll call that the side length squared times dx, give it some thickness, and then we're going to integrate or add up those slices from 0 to 4. Okay, so that's what my volume is going to look like. The side length s here, we can calculate s is going to be the upper function minus the lower function. Okay, so there's our value for s, so I'm going to rewrite this integral. It's going to be the volume from 0 to 4, and 2 square root x minus x and we're going to square that side length and give it a thickness of dx to give it some volume. So the first thing then is that we're going to expand this. We expand this out, so we end up with 4x minus 4 root x times x is x to the 3 over 2. So I'm going to write that as a fraction, 3 over 2. X times x is going to be x squared. Now I can integrate those terms independently. So this becomes 2x squared minus, and we're going to add 1, so it's going to be 4x to the 5 over 2 divided by 5 over 2 plus x cubed over 3, and we're going to integrate that from 0 to 4. Okay, so I'm just going to clean this up a little bit and then evaluate it. So volume equals 2x squared minus 8 over 5 x to the power 5 over 2 plus x cubed over 3 from 0 to 4. And then plugging that in, I'm going to end up with 2 times x squared, so 2 times 4 squared is 32, minus, that's going to be square root, so 4 square root is 2 to the power 5 is going to be 32, so it's going to be 8 over 5 to the times 32 plus 4 to the power 3 is 64 over 3, and then I'm going to be subtracting 0. So adding that all up, I end up with 32 minus 8 over 5 times 32 plus 64 over 3, and that's going to give me 32 over 15 as my volume. So I end up with 32 over 15, and that's going to be whatever that unit is cubed, because we're talking about volume.